one of the tensions that I've always felt in the Agile space, Agile really grew up out of the software engineering world, right? The Kent Becks and the Martin Fowlers of the world, and then it got kind of taken over. What I'd say about like the Jeff Sutherlands and the Ken Schwabers of the world, right? It became almost like a Scrum XP dichotomy, and I think one of the things that we see quite a bit are folks that get introduced to Agile that don't really have the deep expertise in, how software is built, how it's architected, how it's run, how it's tested, how it's deployed, all those kinds of things. So we kind of wrap development in these management practices, but sometimes because we say we're doing Scrum and Scrum doesn't necessarily require XP practices, then we can kind of break things a little bit. So maybe Kevin, you could lead us off. I would love, as a developer, what would you want maybe your Scrum Masters, your Agile coaches, your leaders in that organization, what would you want them to know such that when they're implementing Scrum or SAFe, what would you want them to be aware of and cognizant of to create the right environments for the engineers to do Agile well? Any thoughts?
It's a great question. The thing that pops to the top of my mind, comes back to what I said earlier around feedback loops, is understanding the 1 to 10 to 30 layers of feedback that a feature is going to need to get to production. So anytime you can move risk to a smaller and faster feedback loop, the better off you're going to be. If you could focus on not just the innermost TDD feedback loop where you're writing a test, writing the code, minimal code to pass that test, and then refactoring it and committing it, but all the way through the cycle. How can you reduce the size of those feedback loops through automation? Right, this is where DevOps comes in, and by doing that gives you the ability to take more risks, experiment more with more things, push things out to production more quickly, get feedback on them, and so on. I think that's the big thing in my mind from a support from Scrum Masters or support outside of the development team, is understanding all of those feedback loops and how to work towards reducing them.
Chris, you led off with the idea, you talked about, the idea of pair programming. I was introduced to that I was at the XP White Book back in the day, something like that. And, the common objection of leaders would be, well, why would I have two people writing the same code, when I could split those two people up and I could write twice as much code? So one of the things that, becomes a barrier to what Kevin's talking about is the idea of economic justification. So how would you create economic justification for building the necessary infrastructure so that you could achieve those faster cycles? Because it's not just a mindset or an attitude or even a practices. There's some fundamental barriers sometimes in how that code is written and deployed that actually make it really expensive to create those feedback loops. How do you create the economic justification for that change?
So I think, it's always difficult when you look at outcomes, it's always, causation can be very, very difficult. It's like the business outcomes that we create for our customers and increased revenue or decreased expense or whatever. Direct causation, if revenue is going to go up $100 million, can you say, okay, it's these features that cause that, specifically these three features? So causation can be difficult. Correlation, a little easier. We over time we show that we're doing these things, and we've got, our customer sat scores are going up and our revenue is going up, and you can kind of start to correlate things. When it comes to, specifically the what are now being called ensemble coding practices, where you have more than one developer working at a time. You can think about it like from an input perspective, an output perspective, and an outcome perspective. And I think a lot of the people we run into are dealing with finance organizations that think in inputs. So dollars per hour, number of resources working, do the math. Very easy to say we've got, X amount of dollars working at that screen at any given time, and, what are we getting for it? And I think we are very bad as an industry at saying, okay, but your productivity went up by this much, and your defects went down by that much, and a cost of a defect is this much for you. So I think those things can be actually measured. I've done it in prior jobs. I actually proved in one job that the worst thing you could possibly do with this system is to have anybody change a line of code. Like, if you just stop, that is the best economic outcome you could have. Because every time you change it, you break this many things, and and each thing costs you about this much to fix, and the benefits you're getting doesn't actually outweigh the cost. So if we're good at tracking metrics around the cost of change, and we can correlate that to then outcomes of what kind of improvements are we getting, in productivity, decreases in waiting. So how does that correlate to waste in the system, and, and productivity and throughput and all of those things? I think that can be powerful. I have run into situations where, even with that economic justification, some people just can't wrap their brain around it. I mean, the example I gave earlier, we had an organization, transformation went from a new product was 21 months and 700 defects and don't touch it, to 3 months, no defects, 20 hours of production support per year. We had the metrics for all of that stuff. And so CTO moves out, new CTO moves in, didn't care about any of that. Just saw two people at a tube and absolutely, couldn't understand why we would do that, and what all this. Why were we writing all these tests when we could write features? And no matter what we gave them in numbers was, just not. It just wouldn't land because of the way that they saw the world in inputs.
Okay.
Not outputs and outcomes. But I think if you can, the outputs are very measurable, and you can correlate to the outcomes. You might not be able to do direct causation. I think in many cases, the world has changed, Mike. I don't think there's as much pushback for allowing people to do this. I think there's more expectation that people will. Mm-hmm. But I still think there's a good case to be made for saying, how valuable is this, right? So measuring throughput, measuring rework, quality, all of those things, and then correlating it to how much value now can we put out to the customer based on the fact that we're no longer doing all of these other things.
Okay, awesome.
Yeah, it's never been about how fast developers can type, right?
Right.
It's always about their problem-solving skills, which is collaborative. If it was about how fast you could produce code, we'd have typing tests for developers. That's never the case.
Yeah, that's an interesting point, Kevin, because sometimes what I'll talk about is it's not a lot of times it's like decision latency, it's waste, it's wait time, it's defects, right? It's all those things that is actually what's driving the cost and the timeline. If we were just clear, so many organizations resist the idea of getting the business and the developers in alignment on even what they're going to build. It's too expensive, it's too upfront, it's too this, and I'm but what's the cost of them not understanding it? They're just building the wrong thing, right?
And if you can get that in front of them faster through the feedback loops and get a reaction from the end users about what's actually being built, you can make directional changes sooner at a lower cost, even if it takes.
That's something that can be measured, though. Time to feedback.
Yeah.